I will be discussing the problem group anagrams. The problem statement says given an array of strings strs, group the anagrams together, we can return the answer in any order. The problem asks us to take a list of strings and group together those that are anagrams of each other, meaning strings that contain exactly the same characters in the same quantities, but a possibility in a but possibly in a different order, like eat, tea, and ate. Each group should contain all strings that can be rearranged from one another, and if a string has no anagram partner, it simply becomes its own group, like BAT. The final result is a list of these groups, and the order of groups or the order of strings inside each group does not matter. The solution code function creates a directory res using default dict list, so every key automatically has an empty list. For each string s in strs, it builds a frequency array count of size 26 for letters A to Z, initially all zeros. Then for every character C in the string, it increments the position corresponding to that character using ORD of C minus ORD of A. This converts a letter like C into an index line 2 into an index like 2. After processing the string, count represents how many times each letter appears in it. This becomes the signature of that string. Since lists cannot be dictionary keys, it converts the list into a tuple and uses it as the key. All strings with the same frequency tuple get appended into the same list in res. Finally, it returns res.values function, which are all the groups of list of anagrams. The time complexity of this solution is big of n into k, and the space complexity is big of n into k. The patterns which are observed while solving this problem statement are: first is hash map for grouping, next is canonical / normalized keys, next is frequency arrays over sorting, the next is immutable state keys, the next one is time space trade-off awareness, and the last one is order agnostic output handling.